Okay, so in this class we'll cover this TEST-12G portion, class 10, chapter 12. Okay, electricity. Now let's start with this question 2. We'll find this on page textbook 229. Okay, 229. Okay, let me read the question for us. Compute the heat generated. So we can just start writing maybe. So as we read the question here, the heat generated, this question mark, that we need to calculate, right? Then while transferring 96,000 coulomb, the unit coulomb, like I said earlier also, if I say rupees 100, what do we understand by this? Yes, because of the unit rupees, we know this is talking about money. Like that, if the unit is coulomb, just as the unit here rupees indicate money, the unit coulomb also indicates charge. SI unit of charge is coulomb. So charge is usually denoted by Q, or some textbook even use C, I think. Q is equal to 96,000 coulomb. So this is the charge that is involved in the process here. Okay. In 1 hour, so hour means, the unit hour means time. So let's write time, 1 hour. Now we know the SI unit, everything has to be in SI unit because here we are doing by SI unit. So hour needs to be changed to SI unit. SI unit of time is second, we know that. Now in order to do that, we know 1 hour is 60 minutes and 1 minute is 60 seconds. So you're going to change hour to second, skipping 2 places. So big to small, so 1 has to be multiplied by 1 step, 2 steps, so double 60, then hour will disappear. Second will come in, so 6 6 are 36, and these 2 zeros can be just put at the back. So this is the time allowed for the charge to flow, right? Simple as that. 1 hour through a potential difference of 50 volts. So here PD. Okay, so potential difference is usually denoted by the symbol V. Here it says it's 50 volt, so it's already an SI unit. Volt is the SI unit of potential difference, so this is the potential difference involved. What is the question asking? Compute the heat. Now here, you see here, these equations we have discussed in the previous classes. We need to know this by memory thoroughly, right? So which H equation match this values Q, T? Okay, I needs to be involved, I think. So I is question mark. We don't know the current yet that is flowing. Current is ampere, okay? Don't get confused. Coulomb is charge. SI unit of current is ampere. Though they are related, they are not the same physical quantity, okay? So here it seems to be here Q, T, V is there. So VT is there. So here, if we could find I, then we could get the H that we need. So let us look at the I here, number 1. Now since we know the first equation in our chapter we discussed was current is charge divided by time allowed for that charge to flow. So the charge is 96,000 coulombs divided by time allowed for charge to flow is 3,600 seconds. So these two can be cancelled as easy as this. Then 6 are 36, then here 6 1s are 6, 9 is there, so 3 remain there. 36 6 are 36, sorry, 6 6 are 36, 0. Then 12 13 14. Okay, so 2 3s are 6, 2 8s are 16, 0. So this is current is 80 divided by 3 ampere, because coulomb per second or divided by second is ampere, right? So we get that current is 80 divided by 3 ampere. So if you have I, V is there. Now we got I and T. VIT. You can use this to find out the heat generated that the question is asking. So therefore, we can simply write H is equal to VIT formula. So V is 50 volt, I is 80 divided by 3 ampere as we got just now. And the time allowed for charge to flow is 36,000 or 3,600 seconds. So it's simple as here 3 is going, so we can do that. 3, 6, so 3 1s are 3, 3 2s are 6, 00. Then just multiply the rest. 5 8s are 40. With that 2 more zeros, so you can just put it there. And here 12 and 00. Let us not multiply the 0, no need. 4 2s are 8, 4 1s are 4. Then add the zeros at the back. 1 2 3 here. 4 5. So 4 8 1 2 3 4 and 5. 1 2 4 5. This much. And SI unit of heat or energy is same. Okay, heat, energy, work. I repeat, work, heat, energy are the same. They have the same SI unit, joules, right? Because why did we put that? Because everything is an SI unit. Potential difference also volt, SI unit, current, ampere, SI unit, time also second. So obviously the heat will also be in SI unit, which is joules. Therefore, you can write here, heat generated in this process is 48, 1, 2, 3, 4, 5 joules. Now, this can be left like that, or some textbook write in standard form. Standard form means, you can see the symbol is not there, means at the extreme right. So shift it 1, 2, 3, 4, 5, 6, then only come up to the first digit 4. Then 6 places you shift, so 10 to the power 6. Either like this also fine, but some textbook prefer like this. Standard form means bringing the decimal after the first digit on the right. So this much joules of heat is generated in the process. Okay, and then next question, 3. We'll do this 2 and 3 in this class, and the rest in the remaining 2 classes. So 3 classes I think we may need. So let's just try question number 3, which is on page 229 again. So let us see there. Let me read the question for us. Electric iron releases 20 ohms. Ohm means it is the unit of, we know, resistance. So R directly 20 ohms. We're so clear and confident about that because this unit ohms, just as rupees says it's money, ohm says it's resistance, right? Ohm is the SI unit of resistance. So here we write resistance. So we write there. Now, takes a current of 5 ampere. So ampere is clearly I current, and both is 5 ampere. We write as we get the information from the question. Calculate the heat developed in 30 seconds. So heat developed is unknown. Time is 30 seconds, already in SI unit, everything. So which formula has R, I, and T to get H? IRT. I think this one, H equal to I square RT. This time to calculate the heat, so it's a matter of adjusting like that. H equal to I square RT. We chose this because in this particular question we have all this value. I is there already, 5 ampere, R 20 ohms, T 30 seconds. So I think this will be quite simple. I square means 5 ampere into 5 ampere because it is square. So 5 ampere into 5 ampere 2 times. R is 20 ohms into T is 30 seconds. So it's just a matter of multiplying it smartly. 5 2s are 10 is easy, I think. Then 1 0 means 100. These 2 gone. 5 6 are 5 3s are 15. Then here 1 0. So we multiply means 1 into 15. 15 1 2 3. So 1 5 0 0. Everything in SI unit. We know the SI unit of heat is, that's correct, joules, right? So standard form means bring it 1 2 3 4 after the first digit 1, so 1.5 into 10 to the power 4 joules also we can write. Right, so we'll do the remaining in the next 2 classes. I hope you're getting it right.